Hello students, in our previous module, we had discussed about representing different type of motion using graph. Today in this module, we will discuss about how to find out equations for those motions using graphical method. When an object moves along a straight line with uniform acceleration, it is possible to relate its velocity, acceleration during the motion and the distance covered by it in a certain time interval by a set of equations known as the equations of motion. So, today we will be calculating those equations of motion by graphical method, and those three equations are your V is equal to u plus at, s is equal to ut plus half at square and 2as is equal to v square minus u square, where u is equal to the initial velocity of the object, a the uniform acceleration, t is equal to the time interval, v is the final velocity and the s distance travelled by the object in a time t. So dear students, let's first consider a relationship between the velocity and time, and we will find out the equation for the velocity time relation. For that, let us consider this particular graph. So in this velocity time graph of an object that moves under uniform acceleration, as shown in the graph, where the velocity starts with an initial velocity of u. Let's not consider u is equal to 0, but with certain value. That's why the object starts from a velocity u and it undergoes uniform acceleration a and attains a velocity of v after a time interval of t. So here we will try to represent this equation of time and velocity. So for that, let us draw a parallel AD to OC. OC is our time axis, so we will draw a parallel AD to the time axis. Now from the graph you can observe that BC represents the final velocity, whereas OA represents the initial velocity and OC and AD represents the time interval. Now if you want to write that BC is equal to BD plus DC, or we can write as OADC is a rectangle, OA will be parallel to DC and OA is equal to DC. So in place of DC we can write OA. So let's see how we can find out the equation for the velocity time relation. So have a look. So here we will represent BC is equal to BD plus DC, which is nothing but is equal to BD plus OA. So here BC is nothing but, from the graph you have seen, BC is equal to the final velocity v, OA is equal to the initial velocity u. So we can write by substituting these values, v is equal to BD plus u, or we can write BD is equal to v minus u. Now from the velocity time graph, the acceleration of the object is given by change in the velocity divided by the time. So here the change of velocity is nothing but BD, because the final velocity is v and the initial velocity is u. So v minus u is the change in the velocity. So how can we write the acceleration? So acceleration will be is equal to BD divided by time t. So we can write BD is equal to AT. From the above equation we can write BD is equal to AT. Now substituting the value of BD in this particular equation, V is equal to BD plus U, then we will get V is equal to AT plus U, or if I rearrange it, we will get V is equal to U plus AT. So this is the first equation for the motion. That is, the final velocity will be is equal to initial velocity plus the product of acceleration and time. I hope you understood this. Now dear students, we will go for another equation, that is the equation for position time relation. For the position time relation, again we will consider the same graph, right. So here what we will consider, that the object has travelled a distance s in a time t under a uniform acceleration a. So in order to find out the distance travelled by the object, we can use that area enclosed within OABC under the velocity time graph. OABC is nothing but a trapezium. So in order to find out the distance travelled by the object when it has accelerated from an initial velocity of u to a final velocity of v in a time duration of t. So let's derive that equation of graph. So have a look how we can derive it. So here what we will consider, as I said, the distance travelled by that object will be s, which is nothing but is equal to the area of the trapezium, that is OABC. That means again the area OABC can be divided. If you look at the graph, the area OABC can be divided into two parts. One is the area of the rectangle OADC and the area of the triangle ADB. So we will take the sum of these two areas, then we will find out the distance travelled by the object. So first we will find out the area of OADC. For that, if you see, if you divide it, we will write it as area of your OADC, which is the rectangle, and the area of triangle, here I am writing area of triangle ABD. So first we will find out the area of OADC, then we will go for area of ABD. So let us represent it as S1 and this one as S2. So for S1, if you go, area of the rectangle OADC, in that case will be OA into OC. From the graph it is clear. You can see the graph once again. The area of the rectangle will be OA into OC. OA is nothing but the initial velocity. OC is nothing but the time, that is the time interval. So here in place of OA, we will replace it as U and OC will represent it by T. So that means we get S1 as UT. Now let's go for the S2, that is the area of the triangle ABD. So area of the triangle ABD will be is equal to half into AD into BD. Now substituting the value, what is AD here? AD is nothing but your time. Let's have a look again at the graph. As OC is equal to AD, that means OC is T, that means AD will be also T. That's why I have substituted the value of AD as T. And what will be the value BD? If you remember from the first equation, when we are deriving the first equation, BD is nothing but the acceleration. So in place of BD, I will place AT. So that will give me half into AT square. That means if I sum it up, the distance travelled S will be is equal to ut plus this equation, that is the part half at square. So, we will summarize it as ut plus half at square. So, this is the relation between position and time. So, if you are provided with the time, you know the acceleration and you know the initial velocity, you can find out the distance travelled by that object. So, here the motion is along the straight line and the object is undergoing uniform acceleration. So, this will be the second equation for the motion. Now, we will go for the third equation, and what is that equation? That is the position and velocity, the relation between position and velocity. So, to find out the relation between position and velocity, we will use the same graph that we have considered for the first two equations, that is the velocity time graph. So, here in that velocity time graph, what we can see, the distance travelled by the object is s in a time of t and under a uniform acceleration of a, that was given by the area of the trapezium O, A, B, C. So, if you find out the area of the trapezium, we can find out the distance travelled by the object. So, let us see how will you find out the area of the trapezium. So, you know the formula for the area of trapezium is equal to OA plus BC multiplied by OC, and that's divided by 2. So, what is OA plus BC? In mathematics also you have studied how to find out the area of the trapezium. So, OA plus BC is nothing but the parallel side, the sum of the parallel side multiplied by the base, that is your OC, and divided by 2. Now, for that, if we substitute the values for OA, for BC and OC, what we will get? OA is nothing but your initial velocity u, BC is nothing but the final velocity v, and OC is nothing but your time t divided by 2. Now, from the velocity time relation, that is v is equal to u plus at, I can find out an equation or derived equation for time, that will be v minus u divided by a is equal to t. So, I will substitute this particular value of t in this equation. So, what I will get here? U plus v multiplied by v minus u divided by 2a, which is nothing is equal to your s. So, if I rearrange this u plus v as v plus u, then multiplied by v minus u divided by 2a, you know that v plus u, that is, and v minus u is nothing but v square minus u square divided by 2a. Now, if I rearrange this, I will get s is equal to v square minus u square by 2a, which is nothing but 2as is equal to v square minus u square. So, here you see the third equation of motion, that is 2as is equal to v square minus u square. So, dear students, you saw how we can derive the equation of motion by graphical method. So, the three equations are called as equations of motion. Now, to see the application of it, we will solve some numericals related to it. So, let us have a look at some of the questions related to these equations of motion. So, the first question in front of you, a train starting from rest attains a velocity of 72 km per hour in 5 minutes. Assuming that the acceleration is uniform, find the acceleration and the distance travelled by the train for attaining this velocity. So, what are the things given to us? We are given a velocity of 72 km per hour. Time duration is given to us is your 5 minutes. So, what we need to find out is the acceleration. So, for finding out the acceleration, what is the equation that we will use? We will use the equation v is equal to u plus at, because the initial velocity is definitely 0, final velocity is given to us, the time duration is also given to us. We need to find out the acceleration. So, let us see how we can solve it. You can also give a try. So, here is the solution for it. So, we will consider that initial velocity is equal to 0, final velocity is given as v is equal to 72 km per hour, which is nothing but equal to 20 meter per second. Time given to us is equal to 5 minutes, which is nothing but is equal to 300 seconds. And as I said, we will use the equation A is equal to v minus u divided by t. Now, if you substitute these values in place of v, u and t, what you will get? You will get a value of 20 meter per second. In place of u, we will have 0 divided by the time 300 seconds. So, if you solve it, you will get the value as 1 by 15 meter per second square. So, this is our acceleration. Now, the second part was to find out the distance travelled by it. So, for that we will use the third equation of motion, that is 2as is equal to v square minus u square. So, let us substitute the values and solve this second part of the numerical. Have a look. So, the formula that we will use is 2as is equal to v square minus u square. So, if you substitute the values, 2 into a is nothing but your 1 by 15 meter per second square. S we will find out, v square is in terms of a meter per second, that is 20 meter per second, that's whole square, and minus 0 square. Now, if you solve it, the value that you are going to get is nothing but 3000 meter, which is nothing but 3 kilometer. So, the distance travelled by that object in that 5 minutes of time or 300 second is nothing but 3000 meter or 3 kilometer. So, this is how we can apply the equation of motion here and solve this numerical. So, dear students, now it is time to take another numerical and to apply the equation of motion, so that we can understand how we are applying different equation of motion to different numericals and to solve day-to-day life problem also. So, here is the question, the second question in front of you. The brakes applied to a car produce an acceleration of 6 meter per second square in the opposite direction to the motion. If the car takes 2 seconds to stop after the application of the brake, calculate the distance it travels during this time. So, here what we see a negative acceleration because the car is coming to a rest. So, to solve this, what we will do here? We have to take the acceleration magnitude as minus 6 meter per second square. And the equation of motion that we will use here is the first equation, that is v is equal to u plus at, and also we will use the second equation, that is s is equal to ut plus half at square. So, just have a look how we solve it. So, dear students, we need to substitute the values and we need to use those two equations in order to solve this numerical. So, have a look at the solution. So here what is given to us? First thing is A is equal to minus 6 meter per second square. Time given to us is equal to 2 seconds. Final velocity as the car is coming to rest, the final velocity is equal to 0 meter per second. So from the equation V is equal to U plus AT, we can find out the initial velocity. So V will substitute as 0, U will find out, A is minus 6 meter per second square multiplied by the time value as 2 seconds, and after solving the equation we will find U is equal to 12 meter per second, and this value of initial velocity we will substitute in another equation, which is your S is equal to ut plus half a t square. So if you substitute these values, we got the initial velocity, we have the time, we have the acceleration, so easily we can find out the distance traveled by the car. So let's solve it by substituting the values. The formula is S is equal to ut plus half a t square. Let's substitute the values. U is equal to 12 meter per second, time is 2 seconds, plus half into the acceleration that was given to us was minus 6 meter per second square, and the t square value is 2 into 2, that will give us 4 seconds square. Now if you solve this entire equation, you will get the value as 12 meter. So we can say that the car has travelled a distance of 12 meter before it comes into rest. So using the two equation of motion, we could solve this numerical. Now dear students, we solved the problems related to motion along a straight path. There is another type of motion also, and that type of motion is in a circular motion. So we will see how an object travels uniformly in a circular path. Dear students, we have observed that when the velocity changes, we say that object is undergoing acceleration. Now the acceleration can be achieved by two ways: by changing the magnitude of the velocity or by changing the direction of the object. So as we say, when the magnitude changes, we say the velocity has changed, and when the direction of the object has also changed, at that time also we say that velocity has changed. Now can you think of any situation in which the magnitude do not change but the velocity changes and we say that the object is undergoing acceleration? So definitely you must have come across this kind of motion in your day-to-day life. You all are young, you must be playing a lot of games, you must be taking participate in athletic. So if you know, when a runner is running in a circular field with a uniform speed, where the magnitude of the velocity does not change, but as the runner is covering a circular path, each point in the circle gives a different direction. That means although the magnitude has not changed, but the velocity keeps on changing due to change in the direction. So in order to understand this circular motion, that is uniform circular motion, let's have a look at a video.
Uniform circular motion. Uniform circular motion is the motion of an object traveling in a circular path at a constant speed. The distance of the object from the axis of rotation remains constant at all times. To illustrate a uniform circular motion, tie a string to a ball and rotate it in circles. The string transmits the centripetal force which pulls the ball into a circular path. The ball travels at a uniform speed as it moves around in a circle. An object moving in a circle constantly changes its direction. Since the object is changing its direction continually, it will not travel at a uniform velocity. Velocity is a vector that has both magnitude and direction. A change in either the magnitude or the direction results in a change in the velocity. Therefore, an object moving in a circle at a constant speed shows acceleration because the direction of the velocity vector is changing. In all instances, the object is moving tangentially to the circle. To illustrate this concept, think back to the whirling ball. If the string is relinquished while whirling, the ball travels in a tangent straight line path. This type of pathway occurs because there is no centripetal force holding the ball in a circular motion. A merry-go-round or orbiting electrons in atoms are examples of uniform circular motion.
So dear students, as you saw in the video, that motion of electron around the nucleus is nothing but your uniform circular motion. There are plenty of examples of such type of motion. For example, a cyclist going in a uniform circular motion in a field. Our earth revolving around the sun is also an example of uniform circular motion, or the satellite that are revolving around our earth is also an example of uniform circular motion. So we say when an object is in a circular path, the velocity, magnitude of the velocity remains constant, but as the direction changes, we can say the velocity changes and we can say it is accelerating. So in our sports meet also, you must have observed, if you have ever participated in the discus throw, or you must have observed someone throwing a discus. Before throwing the disc, the participant rotates his body in a circular motion and then he throws that disc, and the moment he throws that disc, the disc travels in a straight path from the point of release. This indicates that at every point in the circle, the direction keeps on changing. So, dear students, we will conclude today's lesson with a simple question. That question is, state the situation where an object with a constant acceleration but with zero velocity. That means we will have a velocity 0, but the acceleration will be a constant. So can you think of any situation like that? So to help you with that, think of a situation when you throw a ball vertically upward. When the ball reaches the maximum height, at the maximum height, the velocity becomes 0, but that acceleration is still acting upon it. What is that acceleration? That acceleration is acceleration due to gravity. Although the velocity has come to 0 at the maximum height, but it is acted upon the acceleration due to gravity. So this is the situation where we can say velocity is 0, but acceleration is constant. So dear students, please go through your NCERT textbook, solve all the numericals. That will help you to understand this lesson with a better clarity. Thank you.